In the previous section, we had looked at Euler paths and Euler circuits. In this current section, we're going to look at Hamilton paths and Hamilton circuits. We're going to explore how these are different than the Euler counterparts, and how these types of paths and circuits can be used to solve a class of problem called a Traveling Salesman Problem, which I'll start abbreviating as TSP. Now, Traveling Salesman Problems involve an entire class of problems that have an optimal route that will hit several points or locations only once. Now, as you can imagine, these problems originated from a salesman needing to go to various cities to pitch his company's product. But as these types of problems have grown, we have found greater applications than just a salesman needing to go to various cities. Every traveling salesman problem will have three elements. One thing these types of problems will have is a traveler. Now, the traveler can be a person, like our salesman. It could be an object or a vehicle, for instance, like a tour bus, or it could even be something like a robotic arm. And there's even more and more applications than these, but just so you can see, the traveler is not always going to be a person. This traveler is going to have to go to a set of sites. These sites are going to be locations the traveler must visit. So moving forward, we're actually going to use little n to designate the number of sites. And finally, these types of problems will normally involve a set of costs. Okay, so this is going to be a positive number that is going to be associated with the expense of travel. Now, again, I'm going to put expense over here in quotes and costs in quotes, because the expense, the thing that we might be tracking for the travel, it could be money, or it could be distance, or perhaps it's time. Okay, so whatever it is, as this traveler goes to the sites, there's going to be something that we're going to be tracking. And normally on these types of problems, when we want to find this optimal route, we're going to want this expense to be as small as possible. Now, this is going to be a problem that's going to motivate us, and we're going to return to it several times throughout this module. So we have a salesman that needs to leave from city A and travel to cities B, C, D, and E. And the cost of one-way airfare is shown on the graph. So a question that's going to be posed to us is, can we find the least expensive way to travel? So I would encourage you to take a moment and actually try to solve this problem, just kind of using your intuition and looking at the numbers that are happening in the graph. Most students, when just presented with this problem, come up with one of the formal algorithms that we're going to explore later on in this chapter. Okay, so maybe as a kind of a motivating route, so you can see what's going on here. Let's say, for instance, okay, so this guy has to start in city A. So let's say he's going to go in alphabetical order. All right, so if you were to go to A to B, that cost of travel would be $185. After B, if he's going to travel in alphabetical order, he's going to go in city C. That would be $121. After C, he would go to city D, which would be $174. After city D, he'll go to city E, which is going to be $199. And then after E, he's going to have to return back home, which would be $133. Okay, so if that is going to be the way he's going to get to all the other cities and then get back home, then the overall cost of this trip to my traveler would be $812. Okay, so this route was just found, I just did alphabetical order. Okay, I had no reason to suspect that this one was going to be the least expensive way to travel, just to kind of show a motivating route, and then how we would figure out the cost of this trip. So then I would encourage you to take a moment then and try to find a different route that allows the traveler to go to all the different cities. He's going to have to start and then come back to city A, and then try to find the trip having a lower value than this one that I just found here. Now, whatever your thoughts are on how you're going to solve this problem, I would encourage you to jot yourself a couple notes down about how you're thinking about pulling off only certain numbers here to complete this trip. So that way you can see then, as we were talking about the algorithms later on in this chapter, you can be like, oh yeah, that's how I was thinking about solving that problem at the beginning. And we're actually going to return to this problem several times over the course of this module and answer this question about what the least expensive way to travel would have been.